If you pick one of those, I'll tell you. But some of that's extra stuff. So we're on the heart sheet. We got to eat and work both, guys.
Oh, my bad. I was talking this now.
All right, so on the sheet with the heart with the period 5 in it, what do we need to work on? You see some, which one? 5 for sure.
Oh, yeah, that's a good one.
All right, so here we go. We're doing number 5 on the review sheet with a heart and a Bible. All right, so we got 2 over x and 2x squared. Those are, lunch must have been really good today. Those are our 2 functions that we need to look at. All right, so the first one says find f of 2. Oh, guys, you know that. What's f of 2?
Why?
You just plug 2 in. So if you plug 2 into f, it's going to be 1. All right, that's all there is to that. You've been doing that for a long time. You're not confused. Now, the next one is equally easy. It says take your f function and add your g function. Done. Now, could we do other stuff? Like get a common denominator and all that? Yeah, but we don't need to. That's our answer right there. Okay? Now, f of negative 3 plus g of negative 2. All right, what's f of negative 3? Dana?
Negative 2
Turn around.
thirds.
What's f of negative 3?
2
Negative 2/3. And then now I need g of negative 2. Now be careful here. This is negative 2 squared, which is 4 times 2, so that's 8. So I am going to simplify that because they're numbers. So I'm either going to say 7 1/3, that would be perfectly okay, mixed number, or I could say 22 thirds. Either one would be perfectly fine. The next one, it's hard to tell, but that's supposed to be a little open circle there. That's an open circle. So it says what's f of g of 4. So what do I start with? F of 4, g of 4. I start closest to the numbers. I start right here. G of 4. So what's g of 4?
32.
32. Everybody okay with that? 32. And then f of 32. So this right here was 32. So I'm going to plug that into f. And f of 32 is 1/16. And then last but not least, g of f of x. Now, start here, start inside, just like you did up here. So what's f of x? You know that. F of x is 2 over x. Dana? Rumor is that you've already gotten one group of kids in trouble today.
What's that rumor?
Let's not do it again.
What's the rumor? What?
2 over x.
What?
So, just be quiet. 2 over x. Take the 2 over x and plug it into g. So that will be 2 times 2 over x squared 2 over x squared is 4 over x squared. Square the top, square the bottom. Now, times it by 2, and it looks like that answer is 8 over x squared. Now, there were a couple more questions for B. I think this was B right here. We wanted to know what is the domain and range of that picture. What is the domain and range? Now, let's focus on domain. Range is a little bit tricky with this one. What is, oh no, it's not everything. It's everything except 0. Can your denominator ever be 0? So x can't be 0, so my domain would be negative infinity to 0 and 0 to infinity.
Yeah.
And then how about this last one right here, this guy right here? What's his domain? Same thing? Because he has an x in the denominator also. Okay? All right, who else? Good question. Who else sees something on this page? Yep.
Number 3.
3. Do you care which one we do?
No.
All right. First one. It is a piecewise function. You're going to have one of these on your test. Alright, so my strategy may or may not be the same as yours, it doesn't matter as long as our picture ends up looking the same. I like to look right here and say, okay, a piecewise function means it's in 2 pieces, and the separator is this line right here where x equals 1. That's where I have one piece on one side and another piece on the other side right here. Okay? Now, what does that look like? X plus 2. It's a line up to, no, up to, or left to. It doesn't make any difference. It's that line right there. You can think of it either way with a line. Either up to or left to. There it is. It intersects right here, the crack in the paper, intersects right there in a closed-in dot. But again, it's been broken. There's 2 pieces. I can only keep this piece, so I am going to keep this side of the picture and erase that. This tells me to keep the left side, less than left. Now, what's that look like? That's another line. This one goes through the origin and has a slope of down 2 over 1. Down 2 over 1. So he looks, I kind of missed my points, but you get the idea. He looks like that. And he gets broken right there in an open dot. And I want to keep that side. So I'm going to get rid of all of this. Get rid of my squiggly there. So no matter what, however you did it, this is what your picture should look like. You should have a nice little ray going this way, a nice little half line going that way.
How do you know we're both the same line?
It's the bottom.
Right there.
Is it always a bottom?
1 and 1, they're the same number.
Will that ever be different?
No, not unless it's got a split. No, on this paper either. But if it is, then you just have 2 squiggles.
Oh, okay.
Where location is that dark dot? Is that 1, 3, or what is that?
Yeah. It came from the top row. If you put in 1, you get 3. what's confusing about that?
Why would you put in the one? Where do you
Huh?
get the one? Where'd you get the one from?
Right here.
You got the bottom one too?
Yeah,
Oh, sorry.
guys, that's huge. I don't know how we missed that. That's where the picture's broken. That's where everything starts and ends. Right there. Where X is 1. Alright, let's go ahead and do the second one too. Since we had some confusion about that one. Alright, so this time I know all the action is gonna be right here at -2. What's that look like, Patton?
Absolutely.
Which is what shape? A V. So I'm not plotting points, I'm drawing a V. I'm drawing my V. It crosses right here in an open dot. And I need to keep, of the two pieces now, my V's in two pieces, I need to keep the piece on the left. So this is just gone. Don't need it anymore. Now what does this one say? That one's a little bit tricky. It is a line, but notice there's only one X value.
So you just put a circle.
One X value. If X is -2, what is Y gonna be? Negative -1? What's -2 plus 1? -1? So at -2, I get -1. It's that dot right there. This is just a point. This says Y equals X plus 1 if X equals -2. So if X is -2, Y will be -1. That's just a point. X equals -2. That's just a point. What's this? That's a parabola. Crosses here. Open dot. Keep the parabola part. Get rid of that little piece right there. I get rid of my squiggly line. I have this little thing sticking out. I have a good chunk of a parabola here. And then my random dot down here.
Would that just be negative infinity?
What?
Domain?
Domain, yep. Yep, the domain is already there. Alright, what else from this page do we need to look at? Come on, I need you to engage or we'll test tomorrow. No point in me standing up here. Which one? 2?
2B.
2 which one? B?
Yeah.
2B. I'm finding vertical, horizontal holes. And I'm gonna go ahead and find my intercepts also. So I want vertical, horizontal holes, x-intercept, and y-intercept. Okay? So my equation, I'm doing B. Well, I can tell right off the bat that this is gonna be 9. How do I know that's 9?
There's nothing to factor.
There's no factoring and
There's nothing.
canceling.
Yeah.
Remember, to get a whole, you have to have a situation like this, right? And there's no way that's gonna happen with this problem. Would everybody agree with that?
Yeah.
Alright, so that's a 9. Now, where do I look for vertical asymptotes? Denominator. The denominator can't be 0, so 3x plus 2 can't be 0, which means x can't be
Two-thirds.
negative 2/3. So your vertical asymptote is whatever x can't be. Vertical asymptotes are cannot be's. Denominator cannot be 0. For the horizontal, I would love to box something in.
What other is it?
No,
So that's
I don't have an x up here.
0?
So I need to stick in a 0 when I'm missing something. So now I've got 0 over 3, which is 0. My horizontal is y equals 0. The intercepts are points, and there's no need for you to get confused. If you are on the x-axis, if you are an x-intercept, I don't know what your x is, but your y is always going to be 0. And likewise, if you're on the y-axis, x is always going to be 0. So to find the y-intercept, you're going to let x be 0. So go back to your problem, put a 0 in right there. So what do you got? If you put 0 in there, you're going to have 1 over 2. That's your y-intercept. Now, remember, that's y. So y equals 1 over 3x plus 2. If I put a 0 in for my y, now I'm going to multiply both sides by 3x plus 2. And what happens over here? It's still 0. Can 0 equal 1? So there's none of these. There's no x-intercept. This thing doesn't cross the x-axis. All right, we can do one more of those. Pick another one. This is part 2. We just did B. Okay?
D.
D. All right, so we're going to answer the same set of questions for this function. It wasn't an issue with this problem, but what should we always try to do first? Factor, right? We always want to factor if we can. So is there any factoring that can happen? Take an x out of the bottom? Now, what do you notice? We can cancel out an x, right? So what does that mean?
Oh, the whole.
We're gonna have a hole, and since it was a plain x, it's gonna be where x is 0. And then we're gonna plug it right back in here to get the y. So if we plug in 0, we get 5 over 4. So the hole is complete. We're done with that. X-intercept, vertical asymptote, horizontal. All right, tell me what else you know. We got the hole taken care of. We had one this time because we were able to cancel. Okay, this is my problem now. Do I have a vertical asymptote? Yes. Because why? There's a denominator. So my vertical asymptote is going to be x equals -4. Because what happens if you put in -4? You get a 0 in the bottom, which is not allowed. All right? How about a horizontal? Do I have a horizontal? Well, you can either check the original or you can check here. It doesn't matter. Can you box these in? No. Because that one's not the same size as this one. Can you box these? There's nothing in the box in here, right? What's going to happen when I put in that 0? I get 0 over 1, which is not undefined. 0 over 1 is 0. If the top power is littler than the bottom, it's always gonna be 0. If the bottom power is littler than the top, it's always gonna be 9. Alright, what about my intercepts? Now I gotta be careful with this because to find my y-intercept, I wanna plug 0 in, don't I?
Yeah.
And I can, and I get 5/4, but that really isn't a point. What is that? That's my hole, so that's really a 9. Because when I graph a hole, what does it look like?
Open.
An open circle. So there isn't a closed circle on the y-axis. Can I set this thing equal to 0? Can I let y be 0? Well, what's going to happen? 5 equals 0? So guess what? There's none of those either. If you graph this picture, it would not cross either axis. All right, now I want to hand your quizzes back. We're going to review again tomorrow, but I want to get these quizzes back to you because some of you had issues.
Actually, this will be
All right, you guys, this is totally not free time. I see some of you packing up. You better still have that pencil out because I don't think there were any surface papers. Even with the notes there. It's a sad state of affairs. All right, we have 2 quizzes happening. One of them has a closed-in heart at the top, and one has an open heart at the top. Okay?